This is worksheet 8.7. This is the next section. I'm going to assign the odd questions. Now this worksheet is challenging because it's asking us to factor a quadratic trinomial where your a value is not 1. So let's take a look at number 1 here. And in order to do this, we have to go back to the old way of factoring. See, the thing is this. You cannot set up the shortcut because x times x is not 2x squared. So the only way, like, you could guess and see if you get it right, but you might have to put a 2 right here and a 1 right there, or maybe the 2's over here and the 1's over here. But it gets a lot more complicated. You cannot set this up and think what times what is c, that if you combine together is b. It doesn't work that way anymore. So this is why we have to go back to our notes and review the long way of factoring. Okay? So step 1 is to multiply a times c. So let me actually delete that and let me write down step 1. I want to multiply a times c. So what is a times c, guys? What's a times c? A is 2. C is 2. What's a times c? 4. 2 times 2 is 4. Step 2, if you read along on your old notes, step 2, think of the multiples of that number. What number? Of the 4. Okay? So think of the multiples of the number 4 that combine together to give you the b value. Tip, make a list. So step 2 is to take your 4 and write down 1 times 4 or 2 times 2. That's all the possible ways of getting 4. And look at the pair of numbers. If I add these together, do I get a 5? No. 2 plus 2 is 4, not the b value 5. 1 plus 4 is 5. So this is the pair of numbers that I want for step 2. Now, we move on to step 3, which gets a little weird. It says rewrite your b value, which is the 5. Rewrite it as those two numbers from step 2. So you're going to rewrite it as 1 and 4. Okay, so the 5, you're going to rewrite it as 1 plus 4. But in other words, you're going to say 5x is really going to be rewritten as 1 plus 4. So check this out. I'm going to circle this positive 5x, and I'm going to rewrite that positive 5x as 1x plus 4x. And of course, I'm also going to bring down the 2x squared right in front, and I'm going to bring down the constant plus 2 at the very end. You get rid of the 5x by rewriting it as these two numbers. The 5x really becomes 1x plus 4x. And that makes total sense because 1x plus 4x is 5x. Now, why would we want to change this trinomial to a polynomial? Why do we change 3 terms to 4 terms? That way we could do step 4, which is factoring by grouping. So if we zoom in and we look at the first term, I kind of already left some space right there. The first group, what could I pull out of that first group, those first 2 terms? What could I pull out? An x. What would be left on the inside if I pull out an x? A 2x plus 1. Now, if you look at your second group, what could you pull out of that one? There's a 4x and a 2. You could pull out a positive 2. And if I do pull out a positive 2, what's left? 2x plus 1 as well. And now that we have a common binomial here and a common binomial here, we're going to factor out that common binomial. I'm going to write the 2x plus 1 right here, and I'll have a x and a 2 left over. So again, the 2x plus 1s are going to be factored out right here into the front. So what's going to be left? The x and the plus 2. So of course, the correct size parentheses answer would be 2x plus 1 times x plus 2. And that's it. That is your answer for number 1. We're doing the odd ones. As you can see, this is going to take a long time. Number 3. So step 1 is to do a times c. And what is a times c? The a value is 2. The c value is negative 5. So 2 times negative 5, that is negative 10. Are you with me? So step 2 Step 2 is to think of the multiples of negative 10, like negative 1 times 10, like negative 2 times 5. 3 doesn't work, 4 doesn't work, that's it. Those are the only two possibilities of getting negative 10, besides changing the sign. So when you think about which pair of numbers, if I add negative 1 plus 10 together, it does give me the b value, which is positive 9. So I'm going to use these pair of numbers to rewrite the b value. So instead of 9, I'm going to rewrite it as negative 1 and a plus 10, of course, with t's. So once again, this 2t squared, I'm just going to write it down here. And now this b value of plus 9t, I'm going to rewrite it as negative 1t plus 10t. So let me do that in blue so you could see it, red it so you could see it. So I'm going to rewrite this 9t as negative 1t plus 10t. And the c value, the minus 5, just comes down at the very end. So once again, we changed the 3-term quadratic trinomial to a 4-term quadratic polynomial. Why did I do that? So I could factor by grouping. So we factored by grouping. In the first group, what could I pull out? Anybody? T, thank you. What would be left on the inside? 2t minus 1. That's right. In the second group, what could I pull out? 5, okay? And that's a positive 5 that we're pulling out. And what would be left on the inside? 2t minus 1 as well, okay? So from there, we could pull out that 2t minus 1 from each group, and we will have a t plus 5 left over. So the final answer is 2t minus 1 times t minus 5. Number 5. Step 1 is to do what? A times c. But what is a times c? 30. Because 2 times 15 equals 30. So that was step 1. Step 2 is to think of the multiples of that number 30. 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6. Those are all the possible ways of multiplying two numbers together to give you 30, besides changing the signs. And you want to see which pair of numbers combines together to give you a negative 11. So if I combine 1 and 30, I get 31, not negative 11. So that didn't work. 2 and 15, if you combine that, it's 17, not negative 11. 3 and 10 is 13, not negative 11. 4 didn't work. 5 and 6 is 11, but you want it to be a negative 11, not a positive 11. So you're going to change the signs. It's going to be a negative 5 times a negative 6. So that is the correct pair of numbers that we want for step 2. Now step 3 is where you rewrite your polynomial, your trinomial, as a polynomial. So the 2t squared, I'm just going to write it right here, 2t squared. Now this minus 11t, I'm going to rewrite it as these two numbers, negative 5 and negative 6. So instead of negative 11t, I'm going to write negative 5t and negative 6t. So let me write it as minus 5t and minus 6t. And at the very end, my c value on the original is 15, so I bring down that plus 15. So I've converted my 3-term quadratic trinomial to a 4-term quadratic polynomial. And now I could factor out of the first group. What could I factor out of that first group? T. What would I have left?
2t minus 5.
And out of the second group, what could I pull out?
T. Nothing but 1.
The 6 and the 15, they both have the multiple of 3. So if we pull out a 3, on the inside we'd have a negative 2t left over. So it's better to pull out a negative 3. That way on the inside we really do have a positive 2t left over. And when you pull out a negative 3 from a positive 15, that would be a negative 5 right there. Because negative 3 times negative 5 gets you that positive 15. And that's a good thing because you have the 2t minus 5 here and the 2t minus 5 there. We're going to pull out that 2t minus 5 and put it out in the front. So 2t minus 5 right there. And what would we have left? I'm not going to do exaggerated parentheses. I'm just going to bring down the t minus 3. And that's the correct factored form right there for number 5. So step 1 is to multiply a times c. And a is 2 and c is negative 1. B is positive 1 here. So a times c is negative 2. Step 2, think of the multiples of that number, negative 2, that combine together to give you the middle value, which is b. What is the middle value b? Positive 1. So you can make a list. Negative 1 times 2, and that's it. That's the only pair of numbers. So there is no list. It's just that pair of numbers. So if you do add these two together, it really does give you a positive 1. So this is what we're looking for step 2. That easy. Step 3 is to rewrite your entire polynomial, your entire trinomial, but as a polynomial. So this 2y squared, I'm going to write it, 2y squared. And then the b value, instead of positive 1y, I'm going to rewrite it as negative 1y plus 2y. And the c value at the very end is negative 1. So there it is. So once again, step 3, the trick is to change your b value to these two terms, okay, by using the two numbers from step 2. Now we're going to factor by grouping. So I kind of left some space between the first two terms and the second two terms on purpose. So I'm going to factor something out of the first group. What could I pull out? Y. And what would I have left on the inside? 2y minus 1. Okay, and in the second group, could I pull out anything? You could just force out a 1. That's right. So I'm going to force out a 1, which is not going to change anything. It's still going to be a 2y minus 1. But that's great because we do have the binomial 2 minus 1 and 2 minus 1 that we could pull out of there. And since we did take it out, what would be left? The y value is left over, and also this positive 1 is left over. And that's it. That's your factored form answer for number 7. If you want to double check, you could just distribute and see if it really does give you that quadratic trinomial, which it will. Let's move on to the next odd one, number 9. Number 9, step 1, a times c. What is a times c? Negative 12. Just remember the 4 times negative 3, the a value times the c value. That's negative 12. That's your answer for step 1, negative 12. Step 2 is to make a list of the multiples of negative 12. So negative 1 times 12, negative 2 times 6, negative 3 times 4. That's all the possibilities besides changing signs. And when we start trying to find the pair of numbers that combines together to give us the b value, we see what? None of those, right? So what do we say about number 9? Prime. Or not factorable. I believe on the back of this worksheet it says prime as a solution. So that's it. Let's try number 11. Number 11, step 1, a times c. That would be 9 times negative 8. That is negative 72. So that's the answer to step 1. Step 2 is to make a list of the multiples of negative 72 that combine together to give you the b value, which in this case is 6. So I'm just going to go for my list. Negative 1 times 72. Negative 2 times 36. Negative 3. I don't even know if that works. Let me get a calculator. So on my calculator, to figure out if 3 times something gives me 72, I go 72 divided by 3. And on my calculator, it gives me a nice number, 24, which means that 3 times 24 really is 72. Okay? And then I want to try negative 4. I want to do 72 divided by 4, see if it works. It does work. It gives me 18. So with the calculator, you'll be able to create this list. Now, negative 5 is not going to work. Negative 6, negative 6 times 12 is negative 72. And negative 7 doesn't work, and that's about it. So which pair of numbers combines together to give us the b value, which in this case is 6? Negative 6 and 12. And it really does give me a positive 6. So I don't even have to change any signs. So I'm going to jump to step 3, which is rewriting my trinomial to a polynomial by changing my b value of 6p to become negative 6p plus 12p. So once again, that first term, 9p squared, it's still there. But here's where the change happens. The 6p, I'm going to change it to a negative 6p and positive 12p. Because negative 6p plus 12p is positive 6p. And of course, the minus 8 is still minus 8 at the end. Now notice that when I wrote my two terms, I put a space between it just so I could do step 1 on factoring by grouping already. Separating the two groups, they're already separated. So I could jump right into factoring out of my first group. What could I pull out of my first group? 3 and a p. And what would be left? 3p minus 2, right? Because 3 times negative 2 is negative 6. And let's factor something out of the second group. What could I pull out of 12 and 8? Pull out a positive 4. And if I do pull out a positive 4, I end up with a 3p minus 2 also. And that's great because I'll be able to take the 3p minus 2 and the 3p minus 2 and factor it out. But what would be left on the inside? Well, you would have the 3p first and the plus 4 second. So there's your factored form answer. And come to think of it, I have been ignoring the very first step I should always do, even before multiplying a times c. Always try to factor out a GCF, right? So originally 9, 6, I could, there's 3s. No, there's not 3 because there's an 8, right? Always try to pull out the GCF if possible. Let's try 13. So I'm glad I just said that because right here we can pull out a GCF. What would that GCF be? 3. So let's pull out a 3 from the whole thing, and what would be left? A squared plus 10a plus 21, right? Now that we pulled out a 3, I could zoom in to the inside of my parentheses, and that is a standard form quadratic trinomial that has the a value of 1. There is no number in front of the a squared, which means we could apply the shortcut. So the shortcut is going to be a right there and a right there. Why could I apply the shortcut? Because a times a is a squared. Again, if I had a 6 right here, I couldn't do the shortcut. But because it's just a squared, no number in the front, I could set up this shortcut. Now I could think, what times what is 21 that if I add together is 10? 3 and 7, right? So and they're both positive. Positive 3, positive 7. Now let's just zoom back out a little, and let's not forget about that outside 3 that I still need to bring down. Out here in the front we had it 3 times, so I need to bring down that 3. Here's my final factored form answer, and we did not even have to use the long method. We pulled out the GCF first, and then we were able to apply the shortcut. What times what is C that if you combine together is B. Number 15 says solve. Okay, solve. Now solving equations, you want answers to the equations, but what we're going to be doing is factoring and then splitting and then solving. We're going to factor first to be able to get multiplication, and then we're going to split with zero product property, and then we're going to be solving. So again, try to factor out a GCF from here, which you cannot. So then you are forced to do the long method of factoring. Step 1, multiply a times c. So a times c is 2 times 3, that would be 6. Step 2, think of the multiples of 6, like 1 times 6 or 2 times 3, that combine together to give you the b value. The b value is 7. So obviously 2 plus 3 is 5, not 7. 1 plus 6 is 7. So we're on to step 3 here. Step 3 is rewriting your trinomial as a polynomial by changing your b value of 7 to become 1 and 6. So I'm going to rewrite the trinomial but as a polynomial. The first term was 2x squared, so my first term's 2x squared. My 7x is going to change to plus 1x plus 6x. Because after all, 1x plus 6x is the original 7x. And the c value at the end was 3, so my constant term right here again is 3. Now step 4 is to factor by grouping. And notice I already left space between them. So I could just factor something out of my first group. What could I pull out of my first group? An x. What could I pull out of my second group? 3. Wait a minute. I probably should have pulled out an x. And if I do pull out an x from here, x times what gets us back to a 2x squared? I'm sorry. A 2 and an x. Okay, how about x times what gets us a 1x? A 1. Let's go to the other one where I pulled out a 3. If I pull out a 3, 3 times what gets us a 6x? 2x. And 3 times what gets us a 3? 1. And now we see that common binomial of 2x plus 1 in both groups. First group, second group. So let's pull it out here in the front. So I'm going to write 2x plus 1 out here in the front. Of course, I'm going to put it in parentheses. And whatever's left over is what's in my second parenthesis. So this x is left over right here. And also this 3 is left over right there. So I have factored, let me write it in the correct size parenthesis. But it didn't ask us to factor, it asked us to solve. So we still have this equals 0 that we need to bring down and put the equals 0 right there. It's still an equation that we need to solve. But now that it's in factored form, I could use the zero product property to get these guys and split them and solve. So set each one of those equal to 0, and then you solve each one of them. So subtract 1, you will get 2x equals negative 1. And the last step would be to divide by 2, because you got to get rid of the multiplication of 2. And what you do to one side, do to the other side. So your first answer is x equals negative 1/2. And your second answer, if you subtract 3 on both of those, you'll get x equals negative 3. Those are your two answers for question 15. What we want to do on 17 here is factor, split, and solve. So we're going to have to use that long process. Again, step 1 on the long process is to multiply a times c. And what is a times c? A is 3, c is 2, and of course b is negative 7. So what's a times c? 6. Now we're going to think, step 2, think of the multiples of 6. It's either 1 times 6 or 2 times 3. That combine together to give you the middle value b. So the middle value is negative 7. So if I combine 2 plus 3, I get 5, which means that 2 and 3 is not the pair of numbers I want. If I combine 1 plus 6, I get 7, and that's great, but I want it to be a negative 7, so I need to change the signs. Negative 1 times negative 6. Okay, so that was step 2. Step 3 on that long process is to rewrite your trinomial as a polynomial, your 3 terms as 4 terms. And how do we do that? We take the b value with the n, and we rewrite that negative 7n as these two numbers from step 2. So instead of 7n, I'm going to write negative 1n minus 6n. Now let's not forget about the 3n squared that's in the front, 3n squared. Let's not forget about the 2 that's at the end, plus 2. Does that make sense to everybody? I changed my trinomial to a polynomial, 3 terms to 4 terms. Now why would I do that? To be able to factor by grouping. And if you noticed, I already left a space between the first 2 and the second 2. That way I could jump right into it and say, in my first group, what could I pull out? We're going to take out that n that's in common in both terms. What would I have left on the inside? We're going to have a 3n minus 1 left over on the inside. Let's look at the second group. What could I pull out of that second group? A negative 2 is the best option. If you pull out 2, it's going to give you a negative 3n in there, and we know we want it to be a positive 3n. So let's pull out a negative 2. That way, when you think about it, negative 2 times what gets us a negative 6n? It's a 3n. And then negative 2 times what gets us a positive 2? Minus 1. So do you guys see how good that is to pull out that negative 2? Because you have a 3n minus 1 and a 3n minus 1. And now you can actually pull out those 3n minus 1s out here. And if I do pull out those 3n minus 1s that are in common in the first group and the second group, if I take this out, the n is going to be the only thing left over right there. And of course, if I take out this 3n minus 1, the negative 2 is the only thing that's going to be left over right here. So there you have it. We have factored using the multi-step process, the long way of factoring. Let me write it with the correct size parentheses. Now, this section is an equation that we need to solve. So I still have the equals 0 here. All I did was factored it, and I factored it to have something times something equal to 0, so I could actually split them, set them each equal to 0, and solve. So I'm going to rewrite it as 3n minus 1. This one could be 0, and the n minus 2 could also be 0. So let me solve the left equation by adding 1 and adding 1. I would end up with 3n equals 1. And my final step would be to divide by 3 and divide by 3. So my answer is n equals 1/3. That's one answer. Now on the other one, you're going to solve it by adding 2, and you will get n equals 2. So those are your two answers for number 17. N equals 1/3 and also 2. Now, once again, before starting to factor using the long method, what's the one type of factoring we should always try first before anything? The GCF. So let me zoom in a little. That way you don't even see the equals 1. Let's just pretend we have a quadratic trinomial right there. I'm going to pull out what? A 2. If I pull out a 2, what's going to be left? 3h squared 4h plus 1. Okay, now what that did, I still have an a value of 3, but now I'm going to be able to factor this quadratic trinomial with the a value of 3, the b value of 4, and the c value of 1, which will be easier than the original one, which had bigger numbers. Does that make sense? So right here, the a value, the a value is 3, the b value is 4, the c value is 1. I'm going to go through the multi-step process of factoring this the long way. Step 1, multiply a times c, that's 3 times 1. I get 3. Step 2, think of the multiples of that number 3 that combine to give you 4. It says make a list on your instructions, but it's just one possibility, 1 times 3, right? And if you do add 1 plus 3, it does give you 4, right? So I'm going to rewrite, this is step 3 right here. Step 3 is rewriting your quadratic trinomial equation as a polynomial, okay? So the 3h squared is still there, but the 4h is going to change to these two numbers, 1 and 3. So instead of 4h, I'm going to put plus 1h space plus 3h. And then at the very end, I have a plus 1. Are you with me? So now I have a polynomial. I have 4 terms right there. And I want 4 terms so I could factor by grouping. So in the first group, what could I pull out? An h. What would I have left? 3h plus 1. In the second group, what could I pull out? Nothing. But I could force out a 1 just to make it seem, or just to continue with this factoring by grouping process. So what would I have left if I pull out a 1? The same exact thing, a 3h and a plus 1. Okay, now that we see that we have a common binomial in the first group and the second group, we could pull out that common binomial. Let's put it out here. 3h plus 1. What would we have left on the inside? An h and a plus 1. So we have factored, and let me write it with the correct size parenthesis here. We have a 3h plus 1 times h plus 1, but let's not forget that we originally pulled out a 2, right? We pulled out this 2 out in the front, so it still belongs right there in the front. And this was an equation to start with, an equals 0 there, so let's put that equals 0 down here. Now this is an equation, and you can do anything you want to an equation, as long as what you do to one side you do to the other. So let's say you didn't want this 2 right here. After all, this is a 2 times some other stuff. If you don't want 2 times, you could simply divide by 2, and it'll cancel out, and what you do to one side, do to the other side. But 0 divided by 2 is still 0. So my equation becomes 3h plus 1 times h plus 1 equals 0 still. And now I could use the zero product property to split them and solve. So one equation is going to be 3h plus 1 equals 0. The other equation is going to be h plus 1 equals 0. So the red equation is easy. That's going to be h equals negative 1. But this other one requires a little bit of work. You subtract 1, you're going to have 3h equals negative 1. And your final step there will be to divide by 3. Divide by 3. So h does equal negative 1/3. So you get those two answers, negative 1 and negative 1/3. That honestly is as hard as it gets. Let's try another one. 21. Should I try factoring yet? No. Why not? It's not even set equal to 0, right? The whole purpose of factoring is to get a multiplication problem. That way you could split it and solve. But this is not even set equal to 0. So let's start by setting it equal to 0 by subtracting 6y, which do to one side and do to the other side. And you could actually subtract the 6y from the positive 18y. So my new quadratic trinomial equation will be 9y to the second plus 12y minus 12 equals 0. And now we could think about factoring. The first type of factoring you should do is factoring out that GCF. What would that GCF be? 3. If I do pull out a 3, what's left over on the inside? 3y squared plus 4y minus 4. And now we could zoom in and look at that inside quadratic trinomial and factor it with the long process. Step 1 is to multiply a times c. What is a times c? 3 times negative 4? Negative 12, right? Step 2, think of the multiples of that number that combine together to give you 4. So what times what is negative 12 that if you combine together gives you the b value of 4? I say make a list. Negative 1 times 12, negative 2 times 6, negative 3 times 4. Which pair of numbers combines together to give you 4? Negative 2 and 6. That actually gives you 4 when you add them together, so you don't have to do any sign change. Step 3 on this long process of factoring is to change your trinomial to a polynomial. So I'm going to start with 3y squared, but instead of the b value being 4y, I'm going to rewrite it as what? The negative 2 and the 6, right? So I'm going to put negative 2y plus 6y. Notice I left some space between them. Now my c value was negative 4. My c value is still going to be negative 4 or minus 4 at the very end. But now I have 4 terms, and now I could apply the factoring by grouping method. So in the first group, what could I pull out? 1y. Okay, so let's just pull out a y. What would be left if I pull out a y? 3y minus 2. Perfect. Let's look at the second group. What could I pull out of the second group? A 2. Okay. Positive 2. And if I do pull out a 2, what's going to be left on the inside? 3y minus 2 as well. So now we could actually pull out this binomial and that binomial, which are in common in both groups. So let's pull out that common binomial from both groups. I have a 3y minus 2 out here. And what would I have left over on the inside? The y and this positive 2. So I have factored it. Let me write it with the correct size parentheses. We have 3y minus 2 times y plus 2. And let's not forget about that 3 that we factored out here. Let's bring that down as well. And it's still an equation equal to 0. Now we already know we could divide both sides by 3. That would just cancel out the 3, and it would still be equal to 0. So we're going to factor, split, and solve. We already factored. Now we're going to split and solve. So this becomes 2 equations. I have the 3y minus 2 equaling 0. And I also have the y plus 2 equaling 0. So up on top, plus 2 on both sides. You'll end up with 3y equals 2. And finally, divide by 3, y equals 2/3. That is one answer. The other answer is simply -2. Y equals -2. So those are your two answers for question 21. Last question, you need to first set it equal to 0. So it's a good idea to subtract 8b and also add 12. That way it'd cancel out. So we're going to subtract 8b and we're also going to add 12. So our new quadratic trinomial equation is going to be 10b squared minus 23b plus 12 equals 0. And then you try to factor out a GCF, but there is no GCF. So we need to go through the steps. And step 1 would be to multiply a times c. So if I multiply a times c, I get 120. Step 2 is to think of the multiples of 120. I want to hit pause and just write down the list. I want to use a calculator, of course. I mean, the easy ones I could do right now, like 1 times 120, like 2 times 60, like 3 times 40, like 4 times 30, or 5 times, let me get a calculator. So we have our list of numbers of the multiples of 120, and we need to find out which pair of numbers combines together to give us the -23 right there in the middle. And that would be 8 plus 15, that's 23 in the middle. However, right here when you add 8 and 15 you get positive 23, so you really want -8 times -15 to be that middle value. So step 3 on this long process is to rewrite our quadratic trinomial as a quadratic polynomial so we could factor by grouping. So I'm going to rewrite my trinomial as a polynomial. So here's 10b squared. Now the middle term -23b, I'm going to rewrite that as -8b and -15b. And of course I'm going to bring down the plus 12 equaling 0. So I can now factor by grouping. Let me erase this to get more space. So factoring by grouping, the first group, I could pull out a 2 and a b, and I would have a 5b left over minus 4. And the second group, if I pull out a positive 3, I will have also a 5b minus 4 left over. And of course, we could factor out the common binomial, 5b minus 4. So this 5b minus 4 and that 5b minus 4, I'm going to pull them out. 5b minus 4 is going to be out here in the front. And what would be left over is simply the 2b right here. And this plus 3 is going to be right there. So there's my factored form, parenthesis 5b minus 4, parenthesis 2b plus 3. And it does equal 0. The equal 0, you just bring it down. And now that we have a equation in factored form, now we could actually split them with the zero product property and say 5b minus 4, that could be 0, or the 2b plus 3, that could also be 0. And we're going to solve both of them. On the left side, or the left equation, I go plus 4, plus 4. So we end up with 5b equals 4. Final step would be to divide by 5. So b does equal 4/5. That is one answer. The other answer, subtract 3 on the other equation. You're going to end up with 2b equals -3. Final step would be to divide by 2. And we end up with b equaling -3/2. So those are your two answers to the last odd question on today's homework, which is number 23.